Awesome. Very much. So, as you heard, I'm Holly Cummins. I work for Red Hat. I'm a developer there. I'm part of the team that helped build Quarkus. And I feel really lucky. Most of the time, I absolutely love my job. I love coding. But every now and then, I question my life choices. A while ago, I was working away, and I was doing something terrible to the internals of Quarkus. And I got this stack trace, and it said, invalid magic. And I thought, how am I supposed to fix an exception that says invalid magic? I don't have the right magic. I missed that bit in learning how to be a computer programmer. This is something, that I think this is a change in our industry. They say that any sufficient... Nope, okay, yeah. I will use this one. Cool. They say that any sufficiently advanced technology is indistinguishable from magic. And I was definitely at the, it's not distinguishable from magic, and it's not even valid magic because I've done it wrong stage. And this is a real change. Historically, I think computers were a lot less magic. They were a lot less advanced. The computer journey really started with punch cards. These were so physical. They were something that we could hold. And then we went on, and we still had very physical programs. So this is Margaret Hamilton with the code that sent the Apollo to the moon. And there was a lot of code, and you could print it out, you could touch it, you could interact with it. The thing about that code, I'm not sure I would like to write that code. I love being a software engineer now. That code, not so much. By the way, Margaret Hamilton was also the person who invented the term software engineer, because she was working with a bunch of rocket scientists, people who were building these spacecraft, and she looked at what she was doing and she said, what I'm doing is pretty hard too. What I'm doing is engineering. And based on that, I think she was right. But all of her colleagues sort of said, that's so cute. No, that's not engineering. What we're doing is engineering. So things moved on. By the 1970s, computers had got to the stage where it wasn't something that you just got in a few special labs. Anybody could get a computer. So this is the first computer that was really designed to be accessible to home enthusiasts. It was about $300 at the time, which in today's money is about $2,500. So that's, say a similar order of magnitude to a top-of-the-line MacBook. This is something that people could buy. But there was a problem with this computer. If you wanted to interact with it, there was two mechanisms. The first was that you had little switches. So you didn't have a keyboard. You had to do your input by little switches. Pretty tedious. If you wanted to know what the answer was, you had little lights, the output binary. You could buy a keyboard and a monitor for this computer, but it made it a little bit more expensive. And when I say a little bit more expensive, it was the equivalent of $25,000 in today's money. So basically, if you had this and you weren't incredibly rich, you were going flip, 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 flash, flash, flash with your lights. Not the most engaging experience. But things have got better. So now we have Java. How many of you are Java folks, by the way? Most hands, yeah. I do other languages, but I'm mostly a Java person. It's my sort of my home language. But we've been doing Java for a while, and of course the industry has moved on. So now, as well as Java, we have large language models. We have prompt engineering. And what this brings us to is this sort of idea of meta-programming. So instead of doing flip, flip, flip with our switches, or instead of typing in the actual program in Java, we can just express an idea, and the computer will sort it out for us. And this is pretty amazing the first time you see it. So I did a talk about a year ago at Foscom in Greece, in Crete, and I made a little demo. So I went to ChatGPT and I gave it the specification, and it produced a whole bunch of code. And I was impressed. And then it kept going, and it gave me more code, and it gave me an explanation. And all of this was generated from just this one little prompt. It was pretty impressive. And so when we look at the kind of that little history lesson of where we've been, the goal of computer programming has always been the application. This is something that we've had as a goal since the 1840s, when Lovelace invented this idea of the computer program. Underneath it, our stack has been sort of steadily building up. So we started with transistors. Actually, we didn't start with transistors, but we got to transistors fairly quickly. Around the same time, we started to develop these machine codes. They were pretty tedious, so we fairly quickly moved on to assembler. And then from there, we moved to the high-level languages, because even assembler was pretty tedious. And then once we had the high-level languages, we needed collections of functions, so we invented libraries. And then we realized that we needed collections of libraries, so we invented frameworks. And now, of course, where we are is we have these AI coding assistants. And you can see every step of the stack, the abstraction is going up. We're going higher level. As time goes on, we get higher and higher level. Maybe in a while we'll have something that's even higher level than the metaprogramming. And I think this is really the story of our industry, has been increasing abstraction. Now, you may wonder why I have chosen a duck for this. There are two good reasons why this is a duck. One is ducks actually have significance in computer science when you talk about abstraction. Who here knows about duck typing? A couple of hands. So duck typing is a computer science concept, and it's based on the idea, there's a saying that if it walks like a duck and if it quacks like a duck and it looks like a duck, then it's a duck. And so duck typing is an abstraction technique for defining the behavior of things and defining how you interact with things. So that's the one very technical reason why this is a duck. The other reason why this is a duck is that it has been scientifically proven through proper scientific research that ducks are the funniest animal. So if you have a joke and it involves an animal, if you swap out the animal for a duck, your joke will be funnier. True fact. I think this is partly because ducks waddle and they just look funny, and it also is because at least in English, the letter K, for some reason, is slightly funny. And so if you have a word with the letter K, it will be slightly funnier than other letters. Who knows? But going back to abstraction, we've been getting more and more abstract. We've been going higher and higher up the stack. I think most of us are pretty happy with this. Definitely not everyone is happy about this. And I saw this firsthand a while ago. Because Quarkus has this really nice feature, or at least I think it's really nice. So it's got this sort of convenience method for logging. Because if you're a Java person, you'll know that if you're doing production code, every time you have a class, you have to initialize your logger. And you have to tell your class the name, you have to tell your logger the name of the class that it's in. This always struck me as ridiculous because it's really verbose, but it's also really error-prone because I have almost certainly copy-pasted that from somewhere else, and it has another class name in it, which I may or may not remember to change. So you have this error-prone, tedious code. And so what Quarkus does is it says, well, you could do it this way, or you could just have a logger method, and you don't have to tell it the name of the class. How cool is that? So I thought, that's cool. And so I wrote a little tweet about it. And so I posted my tweet. And then I started to get some replies. And the first reply said, it said, horrible, all your logging now depends on Quarkus. I see now issue in initializing the logging. And it went on, and someone else said, a generated code is only the business marketing. If the one is not able to write a simple code and depends on generated code, then he is not a developer. Here should be SLF4J API and no JBoss, no Quarkus logger. Similar with Jakarta API versus Quarkus classes. So you have this idea that you're not a real developer if you use these convenience methods. How dare you make life easy for yourself? What were you thinking? And I think, this is an idea that you see repeated over and over again. This idea that if you're using these higher level things, you must be a stupid developer. You must be lacking in skill. So there's, definitely this hierarchy that as you go to the bottom of the stack, you're really, hardcore and cool. And if you're at the top of the stack, then you must be lacking in skill. And, this is definitely the sort of what Margaret Hamilton experienced, because she was working at the software level. And when she talked to hardware people, they were like, oh, yeah, you don't really have any skills. You're just working in software. And I think, you can see fundamentally that this is not true. Because if any of you have ever tried to use CSS and tried to get something centered on a web page in CSS, you will know this is not trivial stuff. This is really hard. But fundamentally, what's going on here is gatekeeping. I love this gate. This is Hadrian's Gate in Athens. And the people who built it, I think, said, we want a gate, but one gate isn't enough. We want our gate to be so gatey that we're going to put a gate on top of our gate, and then we've really got a proper gate. But you see this gatekeeping idea everywhere. And sometimes some of the things that people said in the past now look ridiculous. So when Java started to become really popular, it was one of the first mainstream languages that had garbage collection. And the people who were using the other languages said, no. And you got all these comments like this of, this is sort of advice to a developer. Avoid using any language that uses garbage collection memory management. I like the way it's in quotes. It teaches bad habits and makes for lazy, sloppy engineers. And then again, you have this idea, when programmers rely on a GC implementation to clean up their mess, they become lazy. You have to do it the hard way, or you're not trying hard enough. And again, this idea that you're just lazy. Garbage collection encourages lazy programming habits, which I've seen in quite a few Java developers. So shame on us, we are lazy. And to sort of see the other side, let's look at Rust. So Rust is a new language, and Rust quite famously doesn't have garbage collection. Actually, Rust does have garbage collection, it's just that it's reference counting garbage collection, not tracing garbage collection. This is the Rust logo. I think actually this is not the right Rust logo though, because one of the things about Rust is that Rust is quite famously hostile to users. You have user-friendly languages, and then you have user-hostile languages. Rust is really, really hard to learn. So, I think this is probably a more appropriate logo for Rust. And the thing about Rust's lack of garbage collection is that there is definitely a penalty that is paid for that lack of garbage collection, not in terms of runtime performance, but in terms of developer performance. And so some people did an experiment, and they sort of hacked in garbage collection to Rust. And what they found, and then they got people to do programming tasks, and they found that people who were using the version with garbage collection were more likely to complete the task. But as well, they did it 3 times faster than the people without garbage collection. So this is like a really big productivity win that you're getting for the garbage collection. And so if you're using garbage collection, you're not lazy, you're just smart. But of course, the reason people like Rust is that runtime performance. Rust has really good runtime performance. And there is this general idea that the higher up the stack you go, the slower your code is. With some things like PHP, this is definitely true. But I think we need to be a little bit cautious with this, actually. This idea that higher level languages are slower, it's not really true. I mean, well, it's mostly true, but sometimes it's not true. And the other thing is, even if it is true, I'm not sure for most cases it actually matters. But let's go back to this argument that it's not true. We can see, for example, that if you compare Java programs to C programs, not always, but Java can run faster than C or C++, even though it's this higher level language for lazy people. So for example, there was an academic study, they did some benchmarking, and in some of their benchmarks, you can see here, on this one, higher is better. Java has the higher score. And here, again, they looked at a couple of numeric functions. For numeric functions, it's where Java is particularly fast. On this one, lower is better. On that first row, you can see C did it in 1 millisecond, Java did it in 9 seconds. Java was terrible. But then on the other 2 rows, Java actually beat C. On that bottom row, Java's 4 times faster than C. And of course, those are micro benchmarks, numeric functions, maybe not the things that we care about now. But Stefan showed this yesterday. This is machine learning inference, something that we all care about a lot. And what they've written, an inference engine in pure Java, and it is a little bit slower than the inference engine written in C++, but it's less than 10% slower. That's probably something that's not going to make a difference in a lot of cases. So that's for C and Java. But you can see this at other levels of the stack as well. So when we look at Quarkus, for example, we're a higher level framework built on top of Java. And a Quarkus application can have higher throughput than a plain Java application. This is a little bit more complicated because the definition of what a plain Java application is gets complicated. But definitely, we can give you a speed up over what you could write yourself. So how can that be? How can you have things at the higher levels of the stack that manage to beat things at the bottom of the stack? Ultimately, it's about the engineering effort that goes in at these levels. And it's about the people working on these frameworks, the people working on these JVM libraries, have an understanding of what's going on below in the stack, and they're able to optimize the program because of this. And this idea of working at one level of the stack, but digging down and knowing what's going on below you so that you can write optimum code is called mechanical sympathy. I think most of the time, most of us can completely ignore mechanical sympathy, which is good because mechanical sympathy is kind of hard. But it is worth being aware that, sometimes you do need this intuition about what's going on below you. And as an example of this, I won't go into this story in too much detail because there's a 1-hour talk that was done at Devox that you can look up. But I want to talk about it a little bit because it's really interesting. When we spend a lot of time doing performance tuning on Quarkus, and we noticed that we had a scalability problem, and that when we would run the benchmark on a machine with a small number of cores, things looked great. But then when we would run on a machine with a large number of cores, then our performance started to drop off faster than we would expect. It turned out that this was actually a known problem. There was a bug that had been raised against the JVM for this problem, but no one had realized how significant this bug was. So we started digging into it to try and understand what's going on. And so our performance engineers, they read 20,000 lines of assembler code in order to figure out what was going on, because the problem was this wasn't turning up. Where the missing time wasn't turning up on any traces. The reason the missing time wasn't turning up on any traces is because the missing time was way, way down deep in the guts of the system, in the caches. And so they couldn't just find the problem. They had to go right down to the hardware level in order to figure out the problem. And they eventually worked out that if you do an instance of check in Java, which of course happens all the time, everywhere, if you do an instance of check and you have a really multi-core machine, like a 32-core machine or a 64-core machine, that's going to destroy the speed of all of the code that comes after it, which is kind of terrible. And there is now a fix in the JVM for this, but I think the fix is maybe in Java 23. Not everyone is using Java 23. So we had to go through the Quarkus code and work around this JVM bug so that we could pass on higher performance to people using Quarkus. And the fixes for this are interesting. So here's one. This is a little bit of internal Quarkus code. And my colleague Martin raised a performance fix against it. And I love this because if you look at the text on the PR, he says, "I'm not a fan of the fix." You always know a PR is a bit worrying when the developer raising it apologizes as they're raising it. And he says, yeah, this is non-idiomatic code. This is difficult to maintain. I'm really, really sorry, everybody, for this code change that I'm about to make. But you know, he made the code way longer and more complicated, so that's why he apologized. This was necessary for us. It gave us a really big performance benefit. The good news is that this is definitely the exception. This kind of situation where you have to write really ugly code in order to squeeze out performance is rare. The JIT in the JVM is an absolute marvel of engineering, and it will do so much optimization for you. And the JIT is most able to optimize code that looks familiar, code that is typical. So your job as a Java developer is to write the most normal code you can. If you write normal code, the JIT will look at your code and go, yep, I got this. I know exactly what to do here, and it will optimize it. But I think probably most of us, you know, unless you're working on low latency trading or online gaming or something like that, that really extreme performance tuning probably isn't what you care about. What you care about is, does my programming environment make me productive? Does my stack make me productive? Does it make my job easier? And you know, really, when we say easier, what we mean is better. And when we say better, actually, what we really mean is, does my programming stack make me happy? That's the most important thing. And of course, like everything else, it depends. So as you go up the stack, in general, things get easier. But it does depend. Definitely when you get up to that highest level of the stack, there is some or maybe. And the other thing is, although in general, as you go up the stack, in general, as we've sort of marched forward through time, programming has gotten easier. Forward progress is not inevitable. Our industry can go backwards as well. There's lots of examples of this. I'd like to give you the example of YAML. When you compare YAML to what came before, it sort of looks easier until you think about it and until you try and do something that's a little bit non-standard. For example, if you have YAML and you want to make a list of countries, so for example, I want to list Greece and Sweden and Norway, how will this get parsed internally? This will get parsed into Greece, Sweden, and false. What? What's going on is that no is a synonym for false in YAML, and so that false is what that no got turned into. And that, again, is one of those points where you just reconsider your life choices and think, I could take up farming. So, yeah, at the libraries, definitely sometimes they make things worse. We see that even more so, I think, when you look at the frameworks. So I started my career around 2000, and I had known Java. And so then I started work, and they said, you're going to be working with enterprise Java beans. And I said, Why did I choose this career? I don't understand. None of this makes any sense. What's passivation? It was a real problem, but it was a truly awful, awful programming model, which is why Spring was invented. And this was a long time ago. Our industry has sort of learned, but you definitely still see movements to say, I don't want to use frameworks, this isn't making it easier. So for example, there's a big conversation in the front-end community about frameworks, and a lot of front-end people will say, don't use frameworks, they're just not helping. And so you get this sort of, my website has no framework brag. And turns out there's even a website about it. There is the frameworkless movement that you could subscribe to if you wanted to. I see where they're coming from. I think this is misguided, because the problem with rejecting this kind of help is that you end up reinventing it. There's a saying from a long time ago. This is Greenspun's 10th rule of programming. He didn't actually have another 9, but he thought 10th rule of programming sounded cooler, so he called it the 10th rule of programming. And he said, any sufficiently complicated C or Fortran program contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Kotlin and Lisp. In other words, if you choose not to use these tools, you'll end up reinventing them and you will do a worse job. And this is exactly like the idea that those who forget the past are condemned to repeat it. Those who reject frameworks are condemned to reinvent them. That's maybe not where you want to spend your time. And of course, it's easy to make fun of enterprise Java beans. A lot of frameworks are a lot better than that. I work for Quarkus. We are a framework. Quarkus, I would say, not just because I work for Quarkus, but because everybody else says it as well. Quarkus makes you more productive. Quarkus makes you happier. So, but there is a reason why people have a problem with frameworks, and I think it comes down to cognitive load. Although, in a way, things are getting easier as we go up the stack, there's also a lot more for us to hold in our head. So if in 1963 you wanted to choose a programming language, you had a choice of 4. Fortran is the only programming language where when they invented it, they didn't have to argue about what language to use for the compiler because there were no other languages. Whereas now, in 2023 or 2024, if you want to choose a programming language, you could do Python, you could do C, you could do C++, you could Java, you could do C#, you could do JavaScript, you could do Visual Basic, you could do PHP, SQL, assembly if you really wanted to. You could do Go, you could do Scratch, you could do Pascal, you could do MATLAB, you could do Swift, you could do Fortran, you could do R, you could do Kotlin, you could do Ruby, you could do Rust, and that's just the top 20 off the TIOBE. You might want to make it a little bit easier for yourself by adding some constraints. So you might say, for example, I wish to use a programming language whose name starts with E. Even if you did that, you have a choice between Eiffel, Erlang, Elixir, and probably some others as well. This is hard stuff. And then, of course, when you go to the library stage, things get even more complicated. If you're using JavaScript and you go to npm.js to choose a library, you have a choice of 1.3 million. Actually, that's not true. In 2020, it was 1.3 million. Now it's 2 million. But of course, you can't just choose a library. You probably need to write a cloud-native application, and that means you're looking at the cloud-native landscape. Good luck with that. You could give it to a child as a puzzle, and the child would cry and ask you to cancel Christmas. So, okay, things maybe getting easier, maybe not. Okay, so what about AI coding assistants? Because I've got half an hour through a talk about the future of programming, and I haven't really talked about AI yet, but now I'm going to talk about AI.
Me up just to let me down. Played the part while I played the clown, but with good prompts we're in perfect sync. My co-pilot and I making strides in a blink. Me up just to let me down. Played the part while I played the clown, but with good prompts we're in perfect sync. My co-pilot and I making strides in a blink. me up just to let me down. Played the part while I played the clown, but with good prompts we're in perfect sync. My copilot and I making strides in a blink.
Yep, so this comes back to this idea of maybe I should take up farming, or alternatively, maybe I should take up underwater basket weaving. So that's a joke. I don't think you can actually have that interaction. This is, Jeroen showed this video at DevOps last week, and I thought it was very good, so I borrowed it off him. But the thing is, even though AI and these tools won't insult you to your face, they may not help as much as we think. Because the problem with these tools, well, these tools have several problems. One of the problems with these tools is accuracy. If you try and search in Google for the difference between a sauce and a dressing, so who here thinks they know the difference between a sauce and a dressing? No hands. Okay. Let's see if Google knows the difference between a sauce and a dressing. The difference between a sauce and a dressing is that sauces add flavor and texture to dishes, while dressings are used to protect wounds. And then I love the detailed description is that a dressing is used to protect wounds and prevent infection while also allowing healing. And you should have 2.5 tablespoons of dressing on your salad. So Google has got completely confused. These tools are amazing, they are magical seeming. They also have limitations. For something like a search summary, that maybe doesn't matter. For our code, it starts to matter more. So there was a study, this is a little bit old now, but they found that the coding answers were wrong more than half the time, but they were presented so convincingly that people accepted them anyway. And this becomes really obvious if you ask it for assistance in an area where you know well. So that Quarkus example that I showed at the beginning, when I looked at it more and when I dug into it, I started to realize that there was problems. So for example, it suggested that I should use the command quinoa build to run my application. Now Quarkus does have a CLI, but the Quarkus CLI is not quinoa. The Quarkus CLI is Quarkus. So this was just wrong. But then there was more subtle errors as well, because it suggested that I add some configuration to my application properties file. One of the really important design features of Quarkus is that we don't have to have that kind of config in your application properties file. So it just missed this whole design point. And of course, sometimes it really, really matters. So a lot of code generated by these tools has security problems. And you can kind of get it to fix those problems if you prompt it and say, could I make my code secure? It should be secure by default, obviously. And so the effect of these tools is that we are seeing a statistically measurable worsening in the quality of our code bases. And we're also seeing a worsening of bloat. And again, I saw this when I was asking for Quarkus assistance, because it gave me so much code. And I was like, wow, that's really good. But 70% of it, when I looked at it more carefully, was unnecessary. And so my initial reaction was, wow, it's made me so much more productive. I've written all this code. But lines of code is not a good measure of productivity for people. And so we shouldn't measure our AI assistance in terms of lines of code. And again, you can see this bloat. You can measure it, because when they look at output from Copilot, they can see that Copilot, well, first of all, people only accepted 30% of the suggestions, so 70% of the time it suggested something that wasn't helpful. But even though it was only producing, even though it was wrong 70% of the time, 40% of the code in the code base came from Copilot, which suggests that there was a lot of bloat in that code. And I think this idea of getting generative AI to generate boilerplate is just totally the wrong idea, because if code is so boring and so predictable that an AI can write it, the solution isn't to get an AI to write it. The solution is to not even have that code in our programming model. Because the thing about code is that we feel like our job is to write code, but actually our job isn't to write code. Our job is to read code. That's where we spend most of our time. So some estimates say we spend 10 times more time reading code than writing it. I've seen other estimates that say it's actually closer to 200 to 1. So why are we having tools that are making the writing part easier if they make the reading part much, much worse by introducing all of this bloat into the code base? Because nobody wants to read comments that says, this method is a getter. That is not helpful. We don't need that kind of software-generated boilerplate. And I think, again, I think about this for my day job because one of the things that we've really been doing with Quarkus is trying to get rid of that boilerplate. I showed some examples already. Here's another one. If you are, for example, using a database and you wish to run tests, as you should, test containers can really help run tests by saving the need to do a whole bunch of mocking. So what Quarkus will do, you can wire in test containers manually in your tests. It's kind of hard work. It's kind of boring. So Quarkus will say, well, I see you're using this database. I see that you haven't configured an external database. I'll just start a database using test containers for you because that will help you get productive quicker. It's really cool. So I sound a little bit miserable and cynical about AI. I think there are some things that it can do really, really well. We spend so much time reading code. AI can help us with this. I heard a story a while ago. They had a legacy code base, and they pointed ChatGPT at it and says, tell us what this code base does, write documentation. And it came back, and they were impressed with most of it, but one bit was wrong. But then when they looked at it more closely, they realized that actually ChatGPT was right and their understanding was wrong. They hadn't understood the code base correctly, but the LLM had been able to do it. So that's really cool. And I think these kind of use cases are important because when we have AI generating code for us, not only is it maybe wrong, it's not necessarily even faster. Does anybody remember model-driven development? No hands. A couple of hands. Yeah, when I started my career, model-driven development was the next big thing. The idea was that we weren't going to be writing code anymore. Does this sound familiar to anybody? We weren't going to be writing code anymore. We were going to be drawing pictures, and we would drag out and drop the pictures, and everything would be easy. It turns out drawing pictures is actually harder than just typing the code. And trying to understand what a code base does when you have 600 little boxes wired together isn't really that good either. So we dropped the idea of model-driven development. And we see this a little bit sometimes with ChatGPT, that it seems easy, but not necessarily. So that example that I showed earlier, where it generated all that code, I had to try 4 different prompts before I could actually generate what I needed. So there was some effort there that was hidden. And this is something that you see a lot again. So a while ago, someone said, I tried being exhaustive with explanations about things like the data range, input shapes, and reasons for parameters. And with enough explanation, it will eventually come to the right conclusions. But it's far more effort to exhaustively explain what I need than to just write the code. So basically, you are having to write a natural language specification for your code to feed it into the generative AI. It may be easier to just write the code. Having said that, so for me personally, I mostly don't find it productive, but the evidence does suggest it helps people. So there was a study recently, so this is quite a recent study, and they found people were 26% more productive with these tools. So why am I saying this didn't really help me if it actually makes people 26% more productive? The thing is, you have to look at the demographics, and different people have different experiences with these tools, which is why you get this kind of mix of messages. The junior developers in the team got 26% more productive. The senior developers in the team, their productivity was about the same. So if you have a lot of skill, it's not going to help you. If you're just getting started, this is an amazing assistance. But again, going back to this idea of cognitive load, the reason that we want these tools is because our cognitive load is really high. We're struggling with cognitive load. And in 2024, the demands of our job, it's not just writing code, and it's not even just writing and reading code. We need to do the apps, we need to do the ops, we need to do the DevOps, we need to do the DevSecOps, we need to do the DevBizOps, we need to do the DevSecBizOps, we need to do the FinOps. And then it gets worse because we have this idea of shift left. So we're no longer responsible for just writing the code and throwing it over the wall to QA. This is a good thing, but it does mean our job is harder. We have responsibility for the quality. We have responsibility for the security team. We have new requirements like observability. We have responsibility for those. You build it, you run it, all of a sudden we're responsible for operations as well. I don't know how to do that. And then, of course, there's the people who are using it. We need to take responsibility for the usability. And then we're running this in the cloud. That can be really expensive. And all of a sudden, we've just put our organization out of business because we got this monster cloud bill because we got the ops part wrong. So we need to be worrying about the cloud bills a lot. It's just a lot. So I think shift left is important, but I think we should be a bit cautious about shift left. And I think instead we should be moving towards this model of shift down. Let the platforms do the work. It's what they're there for. So we can take all of those concerns, instead of trying to home roll solutions for them, move them into the platform. And then that means that we as developers can focus on the usability, things that we really care about. And in fact, even the quality, hopefully that's something that if we have the right framework, if we have the right tooling, it makes it harder to make mistakes, and so the quality is higher. But I've been talking about the future of development, and there's one question I haven't answered yet, which is, of course, the biggest question. Will AI take our jobs? Does it matter if our jobs become harder or easier because we won't even have them in the future? AI is not going to take our jobs. If you look at the number of professional developers in the world since the 1940s, when computers were invented, you can see it was a tiny number in 1940. Once we invented assembler, the number went up. Once we invented high-level languages, the number went up more. Once we invented libraries, the number went up. Once we invented frameworks, the number went up. I see no reason that once we invent AI coding assistants, this new level of abstraction, the number isn't going to go up more. Software is not going away. And this is in contrast to a lot of other industries. Does anybody know what a knocker-up is? It is a human alarm clock. It is a profession that was invented because of the Industrial Revolution. People needed factory jobs. They needed to wake up in the morning. They did not have alarm clocks. They employed someone to go round and knock on their window. This profession lasted for a surprisingly long time. It lasted until the 1940s in England. There were still knocker-uppers. But of course, this job eventually went away. And it's easy to see why, right? There is finite demand. Only people working in factories need to get woken up. As well, nobody, no matter how good a knocker-up you are, nobody needs waking up more than once a day. You don't say, oh, I enjoyed getting up at 7 so much, I'd like you to come back and wake me up at 2, right? There is a really limited demand. This is completely unlike software. The more software we have, the more we want. So we have software to do stuff, and then we have software to do more stuff, and then we have software to bypass the advertisements in the software, and then we have the arms race where the software, the ad blocker, anti-ad blocker, and then we have monitoring software, and then we have debugging software, and then we have IDEs and management software, and then we have now where we are now, where we have software to write the software, and then we have software to manage the software, to write the software because we need to externalize our prompts, and then we have software to try and avoid Skynet because at this point we've got like quite a lot of software that we need to take care of, and then we need software to tell people about software, and then we have software to work out the meaning of life, and then we have software to gamify software. The demand for this is infinite. That doesn't mean our jobs are not going to change. I think just as nobody would accept people writing at the speed of writing assembler now, the productivity expectation for us in the future is going to be higher. And as well, the generated code is there. The generated code is coming. we interact with it differently than we do with handcrafted code. We probably have to spend more time debugging it. That's where we are. So with that, just to wrap up, I will die on the hill that abstraction is a good thing. To reduce your cognitive load, shift down, and that makes the shift left that we're being expected to do easier. Don't generate boilerplate, eliminate it. If you're designing systems, design them so that they don't have the boilerplate. Be aware of the limitations of coding assistants. They are great at typing. That may or may not be what you actually want to do. And then finally, I think we're all really lucky. It is fantastic to be a developer. It has always been fantastic to be a developer, and I think it's going to continue to be fantastic to be a developer. So with that, thank you very much. I do have stickers. I am terrible at remembering to give out stickers. I have Quarkus stickers. Please come see me if you would like Quarkus stickers. And those are the slides. Thank you.